I want to show you how to use your TI to do the Poisson. So I'm going to do number 14. I actually did this in Excel as well, but I'm going to go back and do the same thing now, and I'm going to do it in on the TI because I want to point out, just like I pointed out in Excel, the difference between the cumulative and the mass probability function here. So the first step is to find the mean. So this says neuroblastoma, which is a rare form of cancer, occurs in 11 children in a million. So probability is this 0.000011. 4 cases appeared in Illinois, which had 12,429 children. So assuming that it occurs normally, what's the mean number? So the mean number then is 12,429 times 0.000011. So this is my mean, okay? Now I want to go and I'm going to use this here. So this is part A, that's my mean. Now using the unrounded mean, find the probability is 0 or 1. Okay, so I can do this 2 ways, and I'm going to show you the 2 ways. So I'm going to go to second vars, this distribution, D-R-I-S-T-R, okay? And I want to go down here to C and D, the Poisson, and you'll see it's got a PDF and a CDF. The PDF is each individual number. The CDF is cumulative. So if I did the PDF of 1, it is going to give me the probability of one case, of exactly one case. If I did the CDF of 1, it's going to give me 0 and 1. So you can see how in this case the CDF would be a one step. But I'm going to show you the PDF first and how we would use that, because again I want to illustrate the difference. So I'm going to click on PDF first. Okay. So then this is lambda, this is the mean up here. So I would, in this case, I would just, because I want to use the unrounded number, I would just do the math right here, and you can. 1, 2, 3, 4, 1, 2. Okay, and then my value, 0. Then paste, okay, and enter. Now what I want to do is I want to add, and I'm going to come in here, and I'm going to go to distribution, and I'm going to do the 1. So I'm going to go back to PDF here. Okay, same mean, but now I want 1 value. Okay, so now what it did is it computed that, added it to the last one. You could have also, simply copied that, done it individually. This is about 11. You can see that's how, you can look at the difference here. If I really wanted to know what the individual one was, I could do it separate, or I could just go back and subtract. So that's the probability of 1. So we can see the probability of 0 cases is about 87%. It's about 12% to have 1. Having 0 or 1 is 99% of the time. Okay, now, so this is how you do it. Now, so if I want to do the CDF, okay, so I'm going to come back here. I'm going to go to the second distribution here, and I'm going to go down. So remember, we wanted C and D, so it's a ways down here. And now I want to use the CDF, the cumulative. So now I'm going to put in the same mean. 2, 3, 4, 1, 1. I got to count or I'll screw up. And then I'm going to put in 1. This always goes up, so this is 0 to 1. Okay? So this is this value. Now, let's look at this. So in either case, B is 99%, 0.991. What's the probability of more than one case of neuroblastoma? So that's the probability of 2, 3, 4, 5, 6, whatever. Well, remember, this we can do in reverse. We can do 1 minus the probability of 0 and 1, which is all we're taking out, right? More than 1 is everything but 0 and 1. So what I want to do here is I want to do 1 minus. It's similar to at least 1, but instead of at least 1, this is really at least 2. So 0.0081. So less than a percent chance that we have more than one case. So 4 does seem to be an anomaly and not by random chance. So hopefully this helps you with this. Mainly, second vars here, this distribution. Make sure you know the difference between the PDF and the CDF. So the PDF is I want exactly one number. The CDF goes up. So if I wanted, 3 and less, CDF one-stop shopping. If I want more, I'm going to have to do 1 minus. I have to use that complement because I'm looking for the other side. And that's the reason we had to do 1 minus in our last step of this one. So hopefully this helps you if you decide to go this method.